compound angles of trigonometric ratios. We'll see the geometrical proof of compound angles. As a part of that one, first of all, we'll prove sin A plus B is equals to sin A cos B plus cos A sin B. Move on to the proof. Let us think that two rays has been originated from the same point. We know that there is an angle between these two. If that angle has been bifurcated by the another ray, then we get two angles, namely angle A as well as angle B. If I join these terminals with the help of a perpendicular, I can get two right angle triangles. If I extend these points with the base, I can also form a rectangle. So by this way, I got triangles as well as one rectangle. What are those rectangles? Only one rectangle is there, PRTQ, as well as ORS, OPQ, as well as OSQ. So these are the geometrical figures within the diagram. We know that in triangle ORS, angle A is given, one angle is 90 degrees. What about angle OSR? This also will be 90 minus A because both are complementary angles. Since RST is a straight line, so we'll get QST angle as angle A. Now let us define some terms with respect to these triangles so that we can go towards the proof. First of all, in triangle ORS, if you take the sine ratio, it will be equals to RS by OS, which can be written as RS is equals to OS into sine A after transposition. Let us consider this equation as 1. Similarly, cos ratio with respect to A in the same triangle ORS, then OR is equals to, we can obtain OS into cos A. That is the second equation. Similarly, another triangle, if you look at, that is triangle OSQ. Here we have sin B, which is QS by OQ, which can also be written as QS is equals to OQ into sin B, third equation. Same in the same manner, cos B is equals to OS by OQ will get, whereas OS can be written as OQ into cos B, that is the fourth equation. We have one more triangle, that is QST. Even in this triangle also, we will get some trigonometric ratios. Sin A is equals to QT by QS, whereas QT can be written as QS into sin A, as well as cos A ratio, that is ST by QS, which can be written as ST is equals to QS into cos A, that is the sixth equation. So we have to remember that we are also using PRTQ rectangle where opposite sides are equal. So what are the opposite sides here we are using in the diagram as a part of proof? PQ and RT. So here I have mentioned RT is equals to PQ or PQ is equals to RT as opposite sides are equal. Let us put all these data into a triangle which is called as OPQ, where I will get compounded angle A and B. For this A and B angle, what will be the opposite side? PQ by OQ will be the ratio for sine. Whereas PQ can also be written as RT, whereas RT has been bifurcated into RS and ST. The third step you can see. Let us go to the fourth step. where RS value is taken from equation 1 and ST value has been mentioned from 6th equation. So we have written as OS sin A plus QS cos A by OQ. Again, if you go for OS value from the 4th equation, you can mention it as OQ cos B into sin A as usual from the previous step. Again, QS can be taken from the 3rd equation as OQ sin B and cos A from the previous step as it is by OQ. If you look at the numerator term, OQ is common. If I take OQ common, already in the denominator we are having OQ, it gets simplified, that is cancelled, and we'll be left with cos B sin A plus sin B cos A, which can be rewritten as sin A plus B is equals to sin A cos B plus cos A sin B. So that is a proof of sin A plus B.